Hello. Hey everyone. So I'm back. Hey Mediocre Pudding. Good to see you in chat. Thanks for dropping by. So I did a stream last week. I was just testing things out and I went through all of the parts that I have for building an Ergodox keyboard. Now, again, this is the first keyboard I'll be building. I've done a bunch of electronics stuff before, but all the help I can get from the community, who people who know about building keyboards much more than I do, will be helpful. Hey Slayer, good to see you in the chat as well. Good, thanks for dropping by, folks. So I started streaming just to kind of get out of this boredom of staying indoors all the time. Of course, I am indoors while streaming as well, but virtually. And one of the fun parts I want to do is take one project at a time. Take it at a chill pace, not to hurry things out. I mean, we keep rushing all the time in mostly everything else we do, right? So I want to take things slow here, and spend some time interacting with you good folks in the chat. So welcome everybody. Hey, so I went over why I want to stream anyway in the last stream a little bit. Of course, nobody was around, so I won't be surprised if nobody saw that. So I have three main objectives. One, dedicate some time to these kind of personal projects. Two, interact with people with diverse backgrounds as much as I can. And three, kind of keep the continuous learning cycle going, right? And there are a few projects I have in mind. The first one I picked up was this Ergodox keyboard. So again, why Ergodox? So I went over this a little bit last time, but again, two main reasons. One, I have some wrist pain, so I'm doing exercises and all, and I wanted to try out if a split keyboard will help me with that. The other thing is I have slightly weak pinky fingers, little finger, so I want to use the thumb clusters more, right? And that's the two main reasons, and of course for fun. What other reason could be better than that? Cool. So what I want to do today is I want to take a quick inventory. I did this a little bit last stream, but kind of make sure I have all the parts, and then tackle the first challenge I have, which is the Ergodox PCB that I have, and the standard Ergodox takes the Teensy 2.0 microcontroller, and I don't have Teensy. I couldn't source it locally, particularly during this lockdown. So I am going to use Pro Micros on that PCB. Now this requires a bit of juggling. The pinouts are different, so I'll be spending the stream today mapping the pins of the Teensy for which the PCB is made to the Pro Micros which I actually have, and correspondingly either I'll have to do some hand wiring to kind of make sure that the PCB doesn't kind of fry the chip, particularly about power pins and so on. The rest of the pins, the data pins, I could just remap in software. So I'm going to use QMK, of course, the firmware, and in there I'll be able to, if I build a table of what pins should be where according to the Teensy, but use a mapped version of the pins from the Pro Micro pinout. So that's at least the plan. Okay, so Pudding, you're asking, do you know to touch type? So I mostly know how to touch type. I've been typing for what, 20-30 years now, but it's not like the standard touch typing. I do my own slight version of it, and usually it's not much of a pain or a speed issue that I have right now, and I'm trying to figure out if the split design with a bit of separation between the two halves and a bit of tenting will help ease the pain a little bit. Of course, as I said, these are just excuses. I just want to build a keyboard. Pretty much that's the reason. Yeah, so the count, yes, so the pin count, I'll go into it with the actual pictures and the actual chips. So what is happening is the Pro Micro and the Teensy internally are the same microcontroller, of course, the 32U4. And then the number of actual pins that come out of the board, the Teensy board, and the number of pins that come out, the data pins that come out of the Pro Micro board are different. Okay, so I'll have to use a small trick. Again, 2 or 3 hoops I have to jump through. So another thing I couldn't source is the IO expander for the other half of the ergodox. So bummer. But what I realized I could do is essentially use 2 Pro Micros, pretty much like say a Lily 58 or something like that, right? And this is supported, so I should be able to kind of use 2 Pro Micros, and hence per microcontroller I'll need lesser number of pins to be used, and I'm going to remap everything anyway. So yes, I have enough pins as per my count. Of course, the devil is in the details, so we'll figure out. Okay. Yeah, good to know that you agree that the ergodox will improve touch typing. So yes, that's one of the objectives. Now I'm not really aiming for speed. I am aiming for comfort here. So let's see where that goes. Okay, let me get started a little bit. So what do I want to do today, right? So first is a quick switch count, just to make sure I have everything. And again, one of the constraints I have is I'm thinking of going caseless, plateless, which is probably not a good idea because soldering the switches will be a pain. Some of the switches, in fact, I think about half of the switches I have don't have the PCB mount legs for the support. So that's a pain. But if it turns out to be too much of a pain, I will actually go and get a acrylic laser cut plate made. But I don't have that right now. So for today, no soldering, just taking the first challenge, which is can I use a Pro Micro in place of the Teensy? And let's see how far we go with that. Yep. Hey, Lieberman, good to see you in the chat. Nice. I'm glad a lot of people from the Indian mechanical keyboard community are dropping by. Good to see you all. Yes, yeah, Pudding. So you say QMK has made split easy to implement, and yeah, that's something that I got encouraged by as I was reading through a bit of prep work. So yeah, the flexibility is great. It's good that mostly all of these designs are open source, so we can learn easily rather than be stuck with whatever a manufacturer did or something like that, or have to spend hours and hours reverse engineering stuff. So yeah, it's good to know that we are using things which are really, really flexible in their design, and that always helps. Cool. So I'll get started. Let me quickly share my screen and see a recap of what I did last time. Okay. So folks, let me know if the audio is okay, music is too loud, too low, anything like that, because pretty much you folks are the first people listening to me on the stream. So any adjustments that are needed, very welcome to hear about those. So what I have here is essentially a quick copy paste of the parts section of the ergodox website, and I have marked some of the decisions I went over yesterday. Last week, sorry. So I have PCBs. I in fact have 3 PCBs, so 1.5 keyboards, right? I can afford to mess up one for now. The Teensy I don't have, so I'm using Pro Micros as replacements, and the spin out mapping and hand wiring is plus firmware changes. These are the 3 things which I'll try and tackle today. Header pins and all are fine. The IO expander I didn't get. Oh, you can't hear the music? Okay, that's fine. Let me increase the... It is meant to be like a chill track anyway, so it's supposed to be pretty low. How about that? Right now it's not playing much, so yeah, good. Thanks for the feedback. Hey, sure. Oh yeah, it's dinner time already. Yes. So yeah, I'm in India. I think a lot of folks are also in India. So yeah, have a good dinner break, folks. I'll be around chugging away at this for at least an hour, if not more. So yeah, thanks for dropping by, Pudding. See you around. Okay, so hey Slayer, thanks for dropping by. Feel free to drop by anytime and help out. Thank you. Yeah, so I am going with Zelios V2 switches, and I do have two Pro Micros which I can play around with. So one replacing the Teensy and one replacing the IO expander, right? And so QMK allows you to have two separate files which you can flash to each half, and then the halves communicate over the regular connection that we have, either a I2C bus or a serial connection, and we can figure that out. Yeah, some of these small parts like resistors and all I need by the time I get to the soldering bit. So I'm not missing these right now. One of my friends has a few spares, and I'll be picking these up from them. All of the others, I mean, jumpers and all are fine. Yeah, cables and all are fine, and keycaps. So I have a kind of a cross section of keycaps. I don't have keycaps which are meant for the ergodox, and so I'm going to kind of use a few other batches that I have to assemble enough for the actual keyboard. But we are a few steps away from that, so that's fine. Oh, Slayer, understood. So you were seeing CR2 Pudding. Yeah, okay. Yeah, thanks for being here. Cool. Right. So what do I want to do today? So what I want to do is do a quick switch count, because I have a mix of 65 gram, 67 gram switches. It doesn't really matter. Just that the main thing I want to know is how many of them have the PCB support, the extra two legs for soldering into the or for kind of holding onto the PCB, because I thought I'll go with just a bare PCB with a small gap at the bottom and a bottom plate kind of a thing. So switches directly being soldered onto the PCB, just to keep things very, very minimal. I don't want to overdo things. But yeah, if necessary, I'll have to do some sort of an laser cut plate or something like that. So I want to know how many have those extra legs and how many don't. So soldering the ones on the bare PCB, soldering the ones which have legs is certainly easier. I kind of try to attach a few to the PCB and check. So we'll start with that count, and then the main thing for today is to start with these pinouts for the Pro Micro and the Teensy, and create like a mapping table, so that the mapping table either I will use to hand wire a few pins, or to take it into a QMK file, which I'll have to, I guess, hack together a little bit, so that I don't have to do too much of hand wiring, right? Because if of course, all the same pins are mostly available in both, because they are the same internal microcontroller. But if I were to hand wire everything, it will look pretty ugly. So the objective is take the power, ground, reset pins and hand wire them, because those you can't mess around with. But almost all of the others are data pins, right? And these you can remap in software. So I want to use the PCB as is with a different brain, essentially. Okay, so that's the main project for today. Cool. Right, so let's see the switches. Okay, let me try out the side view. There. So this is my current daily driver. It's a Vortex Cipher, which I have put SA chalk on, and I'm liking it so far. Of course, the split spacebar I couldn't find replacements for, so it looks ugly. This SA chalk set is probably what I will use for my ergodox once that is ready. But yeah, this is it for now. I was talking about this last stream as well. These parts I have sourced from, or begged, borrowed, and stolen from a lot of people in our Mechanical Keyboard India community, both on Reddit and on Discord, a couple of servers. So yeah, thanks to everybody, and I'm trying to reach out to those folks to see if they would stop by at some point of the stream and chat about it. Cool. So let me open the switches. Hey Lieberman, yeah, so I like the Vortex core a lot, pretty much because I got it for quite cheap. I bought it in the US. I was on a work trip there, and this was on Amazon unboxed. So there was like a $20 discount on it. So I kind of got this for roughly $60, the whole keyboard, and like it seemed like a really good deal, and I just went for it without much thought. But I'm liking it a lot, and like redressing it with SA chalk, kind of makes the whole setup look that much better. So yeah, it's fun to kind of move around keycaps and so on. I feel like preaching to the choir here, right? Because all of you folks are into keyboards a lot more than I am. I am mostly been an enthusiast user and getting into building some. Okay, so Lieberman asks, what switches does it have? So currently this one has Cherry MX Browns. I personally like tactile switches. I've been using blues for a very long time on old keyboards, but they're too loud because right now this is me, right? And just 1 foot away is another workstation which other people from home use. So you know why I can't use clicky switches anyway. I don't like the silent like red like linear switches because they don't have any feedback. So pretty much what I could get off the shelf in a what switches I could get in an off-the-shelf keyboard are MX Browns. They are available very reliably from every off-the-shelf keyboard manufacturers. But it kind of didn't make sense to stick with MX Browns when you're building your own keyboard, right? There's so many tactile switches. So I hunted around, and one of the folks on the MK India Reddit had these Zelios V2 switches lying around. So I got those. And let's see how many of what type do I have. So not sure if this is fully visible, but there are slightly different shades here. Let me see if the camera will focus. Right. So the darker one here is the 67 gram spring, and the lighter one here is the 65 gram spring. They are, I can hardly make out any difference at all. I think the difference might be in the bottom out force, but actually pressing the switch hardly has any difference. So I'm happy about that. But let me show you what difference I actually have. And if you see these, okay, this won't focus very easily. Yeah. So this one has these 2 extra pins, right? Here and here, the plastic legs, right there. Right. So the plastic legs hold on to the PCB, and it's much easier to directly solder switches onto the PCB if these plastic legs are present. So some of them have it, and this one, for example, doesn't. So this is just the center stem and the 2 contact pins. So let me bring in one of the PCBs. So this is the one half of the Ergodox PCB. I have some weird lighting setup, so you can see some reflections, but bear with me on that. Right, so here, right, on this side, I mean, this is the left side, let's say, and if I use one, let me attach one switch here. So this one has the extra legs. So there you go, right? Doesn't fall off. That's a good sign. However, if I take one which doesn't have the legs and then put that in, you'll see what I mean. So you see how much, you see this, right? And if I just tilt it, boom, out it falls. So of course, once you solder the switch in, it doesn't really make a difference. because if you have been able to position the switch properly and solder it properly, after that it's all okay. But the whole process of soldering, holding the switch in place, is much easier if it has legs. Usually this doesn't cause an issue because a lot of folks just, a lot of folks don't solder switches directly to the PCB without a plate in the middle, right? So if I had a plate, I would be snapping these switches into the plate, and that is how all the switches will be held together. Then I could just turn the plate over, push in the PCB, and solder it all up. So what I'm trying to do first is take a count of how many of each type I have. So let me do that. Let's say switch inventory. Let me share my screen again. So I'm making a quick sheet here. Switch versus spring weight. Has PCB legs. So there would be 65 gram weight legs, yes. And essentially I want to count, so that's the main part there. It's 65 legs. It seems I have all the variants, so that's a little weird. Okay. Right. Okay, so let's start counting. I want to make this quick because it's not very exciting thing to do, but yeah, it needs to be done anyway. Thought I'll use this to quickly do some stuff. So this is 65 grams with legs, right? So we make a bit of a sorting bin here. And I'll switch back to the side view. If this thing will focus. Come on. How do I convince this guy to focus now? There you go. Weird. Right. So there's another one of that type. Okay. So this is 67 with the legs snipped off. Okay, I think that's a 65 with the legs snipped off, or is there? Yeah, I think the color is a little different. Another 65 with legs off. This is a 67 with legs on. Right, so as I said, the set has all of these types. The 65 with legs, 65 without legs, 67 without legs, and 67 with legs. Okay, so without. Okay, let's quickly go through this. 65 with, 67 with, 65 with. Feel free to chat about anything. One of the reasons I wanted to even do this stream is instead of building it in isolation, right? I mean, the project is kind of a distraction. I just wanted to kind of spend some time chatting with folks anyway about anything. So anybody in chat here building a keyboard right now, or have their eyes on a keyboard they want to buy? Let's talk keyboard, folks. Okay, this is. Let me see if I can get it to focus here for a bit. So I'm using the PCB to coax the camera to focus, yeah. And it won't stay there, so yeah. Weird. 67 with legs. 65 without. 65 with. 67 width, 65 width, 65 width. Okay, a lot of them are coming out with legs, so I'm happy about that. So one of the reasons I like the Z0E switch, particularly the Z0E2, is that the tactile bump is right at the top. It doesn't have much of pre-travel at all, right? So this is the switch without the completely unpressed switch, and and that's the bump there. So it's pretty good for somebody who likes tactility, and you get that feedback very, very quickly from the switch. I'm happy I found these because it's pretty hard to source anything in this current world situation. So yeah, thanks to the folks who had it. I'm hoping the folks who kind of sold / lent / allowed me to steal a bunch of these parts from them will drop in at some point, so I can thank them on stream then. Okay, a lot of them are turning out with legs. This is what I was hoping, because the more I have with legs, the easier it will be for me to solder everything together. So Twitch's auto mod feature, which I have enabled, got your message because of the word lube there, Superman. I mean, weird. Yeah. So am I planning to lube these switches or use them stock? So I would like to lube them, but I don't think I have the time. So it's a little bit weird. As much as I would want to spend more time on these projects, and that's why the kind of chill nature of the stream, at least that's an aspiration. Time is usually short, and right now I get to spend barely maybe 2 hours a week on this project. So yeah, as much as I would want to lube them, I think they're going to get this batch at least is going to get used unlubed, just stock. Okay, good. More switches coming up with legs, so that's nice. So some of these switches have been used before. So they were on they were actually soldered onto a PCB. I mean, they were soldered into a keyboard. I think one of them was hot swap as well. So that's why there is a mix of a few. So some are fresh out of the bag spares that the person had, whom I bought it from. And those still have the legs on, but you can see here that they had snipped off the legs. Sorry, they had snipped off the legs for the ones that they had used, right? As one does. All right, we have another guest. Hey, GRK. I'm going to call you just GRK. Hi, thanks for dropping by, folks. So GRK, you're asking where did you source the switches from? So this entire project, I have, the only thing I have bought from a actual vendor is the microcontroller, this stuff. So it's still packed. So this I got from robo.in, the website, local suppliers here in Bangalore. So rest of these parts, the switches, the PCBs, the diodes, right? All of these things I have, as I was saying, bought or stolen or kind of been handed down by other members of the mechanical keyboard community here in India. We had a meetup, I think, in September to 2019, which is when I got my hands on the PCBs, and switches I bought from somebody whom I found on Reddit, and I'm hoping they will drop by in the stream today so that I can thank them on stream as well. And so yeah, it's been a very collaborative kind of thing, at least sourcing parts. And most of these things one can order online from places like AliExpress or Banggood, but all of those places ship from somewhere outside India, and imports into India are completely screwed up right now because of the COVID situation. So I had to kind of wait a lot and assemble these parts together. That's why, if I were to order switches, I would just order one type, right? And I won't have to do this sorting. But it kind of makes it a lot more fun to, I made a lot of connections within the community because I was just asking people for help on Reddit and on Discord in various servers. So yeah, that's pretty much how I got these switches. So what I'm doing right now, GRK, is sorting these switches into 4 types. So there are, I think I missorted one. So these two are, they have slightly heavier springs. The darker stem gives that away. I'm not sure if you can actually see it because of the lighting. But they either don't have some extra legs or have those extra plastic legs, right, which you can see here. Yeah, these plastic legs, right? So I prefer using the ones which have plastic legs because they're much easier to solder into the PCB. So I'm just sorting them right now. Yeah, one of the reasons I'm even streaming this is so that I can keep chatting with people. So yeah, thanks for dropping by, GRK. Okay, this one doesn't have legs. Okay, let's get through this quickly. Wait. Why am I trying to get through this quickly? So if anybody spots me hurrying up, please say slow down in chat. Because one of my personal goals for this stream is to keep it very, very chill. No rushing, no deadlines. Just take it at the pace at which it is enjoyable, joyful, right? And because I think in our day jobs, we just keep going into rush mode for everything. And I want this stream to be like a sanctuary of time where we prioritize pleasure or joy over speed. So yeah, if you find me speeding up for whatever reason, just ask me to slow down. So some of these pins are bent a little. So at some point I'll have to straighten them out. But I'll get to that when I'm actually soldering them. So it's easy to do with some tweezers or pliers when I'm actually soldering them, which won't happen today. I'm yet to get my hands on some soldering supplies. So I think a few decades back I used to do a lot of electronics work, mostly into robotics and just making random circuits. But that was a previous life, and now I've mostly gotten into software and trying to revive this hobby a little bit and see if that still excites me. I think one reason to hurry up a little bit is I actually need a keyboard. In fact, I need a keyboard with exactly one key. So the reason for that is we need a shortcut way of muting and unmuting Uh, the So my kid has online classes, given the current situation, and we need a one key keyboard in which they can themselves mute and unmute. And right now I'm having to take this keyboard, plug it in, and then I don't have the keyboard to work with, so it's a little bit weird. Hey Zorbidorb, thanks for stopping by. Hello. So we are just sorting these keys based on whether they have PCB legs or not, and the switch weight, which is indicated by the color of the stem. These are S0E2 switches, and I just want a head count of how many of each type I have so that I can plan accordingly. Good thing is most of them are turning up with legs. Okay, I think I may have 3 colors of switches, or maybe I'm just seeing things. So this, and this. Aren't these 3 different shades? They look 3 different shades to me. I'm not sure if it's very visible on the camera. Yeah, they look different, right? So, okay. I thought I had only 65 gram and 67 gram switches. By gram here, I mean, I know a few of you in the chat aren't like deep into keyboard terminology and all, so I'll try to explain a little bit of the terminology or avoid using it. So these switches have different weights of springs, so how firm they are when you press them, right? And they're all from the same manufacturer, but to distinguish which ones are lighter springs and which ones are heavier springs, they use different shades. So far I thought I had only 2 types, the 65 gram and the 67 grams, but this looks like either a 60 gram or a 62 gram, which is also available. I don't mind the differences. It's just interesting to see the so many different variants here. Hey Andreophile, I am so glad you're here. So I was just talking to folks about where I got these switches from, and I have a hunch you know the answer. So Andreophile, where did I get these switches from? Yeah. So Andreophile says you got them from a great man indeed. Yep. Awesome. Hey, so I see a lot of you know each other. I think we all hang out in the same Reddit groups, MK India, or subreddits. Why am I saying Reddit groups? Or on different servers on Discord. But yeah, not in the same server. I know what you mean. Right. So I got these switches from Mr. Andreophile here, and I'm glad he's here. So what I'm doing right now, Andreophile, is sorting these into groups, not just by spring weight, but which ones have these extra PCB legs and which ones don't. Because for various reasons I was talking about, I am currently planning to directly solder them onto the PCB, and that's much easier to do when they have legs, the PCB legs. So that's my current activity here. And suddenly I realized there are actually 3 variants of the Zelios V2 here. So are there actually 3 variants? Because you know more about these switches than I do. So do you think there should be 3 variants, or what's happening here? I don't know. I don't mind, of course. I'm just happy to have these. It's just curious why there are so many variants. Oh, awesome. So Andrew File says he bought about 500 of these switches over a long time. Yeah. Yep. Good. I'm glad I have some fun switches. So the other set of switches which are mostly going to remain in the bag are these Cherry MX Browns. This is probably the last time you'll see them on stream. I didn't want to use brown switches because I have two keyboards, this one and this one. This is a Vortex Race 3, the one in my hand, and this is a Vortex Cypher. Both of these have Cherry MX brown switches, and I like them because you can get pre-built keyboards easily with them, but they're not very exciting beyond their availability and the fact that they're tactile. So, hey Mainel, hi, thanks for dropping by. I'm glad to see a lot of folks in here just doing some basic prep for this Ergodox build, and I'm happy to see a lot of folks joining in. Part of the reason I'm streaming is to just chat with people and kind of get some interesting time spent with the folks. I find chatting or interacting on Discord and Reddit a little bit out of sync, right? It doesn't give the feel of a conversation. It's more messaging, asynchronous, and so on. Yeah. Aha, nice. I'm reading what you just said, Andrew File. So what you're saying is, that's a great idea. So take two switches, make them kiss like this, and press them together. The heavier switch will press the lighter switch in. Is it? Seems to be doing the reverse. Interesting. Okay. So maybe it depends on what else it is latching on. Okay, I don't think this is very visible. Let me try to get some focus in. Yeah. So this is a 67 gram S0E2, the darker one. And that's the lighter one. Oops. It's hard to look both ways. Yep. It's awesome to learn these tricks, man. Thanks for dropping by, folks. Let me catch up on chat. Yep. Yeah, no, I said main L. At least that's what the Twitch name is, right? So, yep. Yeah, darker is heavier, Zorbit, and I don't think we have 78 gram ones. Do we, Andrew File? They don't seem that heavy. They're very, very comparable. So it sounds like 65, 67, 62. Nice one. So Andrew says 78 gram Zelios are for nuke launch buttons. Yeah. You'd have like 78 kilogram ones for those. Okay. Did I mix it up? No. Let me see. So I'll just group them and figure out how many of them have those legs. These two sets have the PCB legs, and these two sets don't. Yeah, 62, 65, 67. Nice. That makes sense. I mean, I keep saying this, but it's really good to have people who share interests interact like this. I think this is something which has happened only in recent years. I would say in the last 10 years or so. Before Reddit, before Discord, you really had to be part of an in-person enthusiast group. I mean, I think Linux users groups or these kind of special interest groups. These things used to be very, very local, maybe city level, and there wasn't much of this enthusiast kind of action going on beyond those groups. Those folks did a lot of interesting stuff back in the day. A lot of the early work on the internet was done by such enthusiast groups, and I see so the physical aspect is not an important aspect anymore, given that we can communicate via streams like this just in person or mostly offline messaging and so on. So it's a great time to have a hobby, and I think it's much easier to find people who share that hobby, right? And I'm glad we have a mechanical keyboard community in India now. So this PCB in a way triggered the MK India Reddit or the creation of it. So the story behind that one, while I'm sorting, is not sure how many of you were there on the first meetup we had in Bangalore on, I think, mid-September 2019. Anybody in chat who was there? Okay, Zorbit says missed it. Andrew says missed it. Yes, I had met Harshit there. That's right. Awesome. So I'll probably share that initial set of tweets of how that meetup happened. Of course, that's not the only reason. I mean, there were people and people wanted to meet up. There's always an excuse to get started, right? I specifically had no clue there were so many people in Bangalore who had an interest in the mechanical keyboard hobby. I thought there must be, given that a lot of us type a lot, and yes, that naturally tends to kind of get people to look around for what other alternative input mechanisms people have and so on. But what happened was the person who I got these PCBs from, I messaged them. I'm not sure if they'll be able to join, so I'll wait for them for the full backstory, maybe next stream. But these PCBs, and I have 3 of them for a very weird reason. So yes, I'm building 1.5 Ergodox keyboards. So what happened was they got their hands on this, I think at a conference or a meetup of some sort outside India, and they tweeted out saying, who wants these, right? Because and I said, I just kind of called dibs on the PCBs and said, I've been wanting a split keyboard for a long time, and I just want to, I just reached out on Twitter. So that was, I think, I don't know, maybe a year ago from now, or maybe even earlier. And finally, many months later, we thought, okay, let's meet and I'll take the PCBs and do something with them. So it started as me meeting the person who had these PCBs. I thought we'll meet for like coffee or something, and I'll just take the PCBs and head back. We thought, okay, why not announce it and let's see if there are other people who are interested. So that's how we started something. And then instantly we got such a huge feedback on Twitter that all of the things got planned in, I think, 2 weeks or so, or maybe a little bit more. And, ultimately we met up, and I think maybe 40 people turned up with the keyboards. I'm not sure. It's awesome how these events happen and how these things come together. So it's always good. Okay, catching up on chat. Yeah, Vim versus Emacs. Of course, not the holy war. The moderator of the MK India Reddit Yes, they are active. I think they're a little busy with some stuff right now. I did check with them, and because we don't see them on the Reddit often. So yeah, we might hear from them soon, hopefully. Okay, goes here. So yeah, it's been an interesting journey so far with this project, and I thought, what better way to keep the community involved in this project than to do it on a stream. So it took some time to set it up, but finally here we are. I did do a first stream last Sunday, about 7 days ago. I didn't really announce it because I was not sure what will happen, but it turned out okay. I talked a little bit about why I'm streaming and so on. So feel free to go and catch the VOD in Twitch itself, or maybe I'll upload it to YouTube somewhere, because I think Twitch deletes VODs after 14 days if I'm not wrong. So yeah. Zorbit, you're right. I know Vim versus Emacs. They are pretty busy with some project right now, and yes, I think they'll be back. Yeah, they're around. Not a coder. Yeah, I know. So if you have flashed a firmware or modified firmware files, you've definitely coded, right? So. But yeah, I know what you mean. All right, we are almost through this set. I think the real reason I'm doing the sorting is to do legs or no legs. So I'll leave the 62 gram ones mixed. It's okay. Oops. Did I mix it up? So the other thing I want to do today is just spend a bit of time doing that pin mapping between the two microcontrollers, the Teensy and the Pro Micro. So that will be something slightly different than just sorting switches. So let's see how that goes. Okay, so let me... Zorbit, no, I'm not really from Bangalore, but I've been here for some time now. I think that describes most of us, a lot of people I know as well. Yeah, Zorbit and Andrea. So what I'm doing is I'm sorting them so that I preferably use the ones which have PCB legs, because I'm going to mount them directly onto the PCB, no plate. That's at least what I'm aiming for right now. Just super simple. May not be the best idea. I think I would like to have a plate, but I don't have one right now, and not stepping out to do a laser cut for now. So yeah. Yep, that's right. I need PCB mounts, so sorting them. Andrew, you did a copy paste and modify some code for the I2C LED display for the gas leak sensor. Oh, nice. That's interesting. So you got it finished. Is it working? Yeah, folks, please do talk about your current projects. It's a lot of fun to figure out what everybody is doing, and I mean, we can't get together that often. Even if we didn't have Corona, I think we all have busy lives. So people won't have time to just come together that often. I'm hoping this kind of a stream sort of setup will be a good way to at least once a week drop in, say hi with the, if people have a little bit of time. So yeah, please feel free to talk about your projects. I am always interested in talking about these things. Okay, I think last two to sort, and they both have legs. Good. All right. So from the looks of it, I think the heavy switches are in a minority. These two are the 67 gram ones. That's fine. That's not a problem at all. Just separating it out. Right. So these two sets have PCB legs and these two don't. Okay. So I'll just do a quick count and then we are done with this part. Catching up with chat. So Andrew says it is a work in progress, learning Python at the moment, planning to integrate with the temperature humidity sensor to calibrate it in real time and get the actual ppm values for the OLED display. Hey, nice. That sounds really exciting. And yeah, I mean, maybe you can talk about it a little bit more sometime. If you need some help, just reach out at any moment. I do a lot of Python coding as my day job, so I'll be really happy to help you all out. Oh, that is awesome, Zorbit. So you are working on a 76% PCB for science. Nice. I'm actually glad that people are kind of really building things from scratch. Somehow I was under the impression that sort of commitment was pretty hard to come by. I think it is hard to come by, but it's really good to see people actually investing that amount of energy into a project, particularly one that isn't part of their day jobs. And I respect that a lot. I have been doing it pretty often in my past life, say maybe 10 years back. But one of the main reasons to do this stream is to invest at least a little bit of time every week onto projects like this. Yep, 75%, that makes sense. So this Race 3, the Vortex Race 3 here is a 75% board. It was the first really serious mechanical keyboard I bought. Before this, it was more functional stuff. So I typed on a TVS Gold for I think 10 years, and on a pretty old, I think it was a clone of a IBM Model M, which I had back in the 90s. I don't even remember the name of that board now. So that was way back. So this one I like a lot because it has, it's surprisingly good value. So it has an aluminum external case, floating key design. So the case is a little bit not coming up to the keys. It has DSA profile PBD keycaps, pretty solid, and programmable to a certain extent, of course, only hardware programmable for now. Vortex have some web-based programming system, but it doesn't work with the Race 3. And it has some alternative keycaps, colors, and so on. All of this for $120, $120 bought in US. So I think it's surprisingly good value, which comes from having things mass manufactured. But that's where the advantage ends, right? I mean, you just get it cheap, but you don't get the flexibility you're looking for. So yeah, that's why this kind of a project. Okay, Luberman says, working on a macro pad with a rotary encoder. My first PCB work. Let's see how it goes. Good. It's really wonderful to see all of these projects going on. Do tell us about how it goes. I'm really interested in catching up with you at some point. So rotary encoders are an interesting thing. I've used them in, a very old project, pre-programming era, in the sense before I started really doing professionally software programming kind of a thing. I used them in a robotics project to act as a remote control. So it's like brings back happy memories. Those encoders were very basic. I don't know what the current encoders are at. Yeah. So Zorbit says, if you take this hobby seriously, passion-wise, you will most definitely end up doing some kind of from the scratch build. Very true. No way of stopping, I guess. Yes. So once you get started, it's hard to stop. And yeah, so the only reason I stopped back in the day was because I moved cities, and I couldn't carry my entire kit with me. So that was literally the only reason I was forced to stop that hobby. And I moved into a job and kind of life took over a little bit. So mostly projects became software projects rather than hardware projects. And yeah, this is a good time to come back after maybe a decade of not doing any hardware projects. So Andrea says, if you want to sell the Race 3, say that it was official movie merchandise and autograph and buy. Awesome. Yeah, these kind of references, only people who are from an Indian background or follow Indian movies at least could recognize. But yeah, that's one of the first things. I think one thing I've been missing personally is a lot of the communities I'm part of have a very US centric focus. And yes, I mean, we work with US companies and so on, but kind of miss the local feel here, right? And it's great to have you all. And I think I would call this kind of a stream thing a success. I am encouraged to continue this at least once a week, where we can catch up and do whatever we want, like share jokes, just talk about our projects. This won't be a keyboard related stream for very long. Once I'm done with this, I'll pretty much move on to something else. So things will switch maybe. So I'm thinking of organizing this a little bit like seasons, right? So this is like season 0, because yes, we are Indians, we count from 0 onwards. And then season 1 might be slightly different themed and so on. Okay, time for a count. So this is lighter switches with legs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. All right. So 28 switches. Yeah, I would say 62/65. 28, right? All right. So what else? Without legs, lighter ones without legs. How many are those? Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. All right, equal number. Okay, so the heavier ones with legs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Interesting. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 without. All right. Zorbid, so you ask, oh, hold on. Andrew said, I blame the lost alignment pins on my hot swap keyboard. Yeah, yeah, that's okay. So it's a common practice to snip off the legs if you're not mounting it directly onto a PCB. Particularly when you're doing hot swap, I think you can't use those PCB legs as is. So yeah, it makes sense to snip those off. And I can see that you probably used the flush cutter to actually snip the legs off, right? All of them pretty much had legs initially. Yeah, makes sense. What do you do for a living? So no, I work for a startup. I won't go into too much detail, just because I'm trying to keep this stream non-work related as far as possible. But yeah, I am mostly into a lot of systems, infrastructure, and also a lot of data processing, pretty much trying to scale apps which use machine learning and AI. That kind of work is what I do for a day job. Andrea says, soldered keyboards with plates still benefit from PCB mount legs. Yes, that makes sense. So I would say mount legs seem like a good idea in general. While looking around for switches, I saw that at least Cherry MX switches are available with and without mount legs. So I guess there is a reason for them to manufacture them. There are two different part codes, the ones which have legs and which don't, at least for Cherry. But in general, I guess it makes sense that unless there is a strong reason like your PCB doesn't support it at all, maybe it doesn't have holes for those legs, or they are used by some other thing, I guess it makes sense to keep those legs. Yeah. Right. So yeah, Luberman. So yeah, Andrew, which keyboard did you mount these switches on? Good question. All right. I saw you reworded your comment. So yeah, sorry about that. I have this auto mod feature of Twitch on because I didn't want. So I've seen sometimes spam bots come in here and start saying random things, and not in my stream, but I was on a stream where this poor fellow was just a person who was streaming, and there were like 3 people in chat. So it didn't seem like something a spam bot would target, but I think they are not targeting much, right? They're just randomly joining streams. So I switched on auto mod, and auto mod has this word based filter. So yeah. It's like, yeah. Sorry about that. I saw that you already changed the word that got caught. So alignment pins become an issue when tolerance is a poopy, which is the case for hot swap boards. Yeah, makes sense. It's good to get all these hints because all of these things one learns with having built a lot of these things over and over again, or dealt with these problems, and that kind of thing doesn't transfer easily, right? So it's great to have people around who can help out on these matters. Yeah. Okay, GK64 aluminum version, nice. Sounds like a good one. Yeah, I don't think Automod is doing any sort of. Okay, I don't know, but it doesn't seem like Automod is doing much of learning from what. I don't know how often they update it. So yeah. Cool. All right, so we have our switch counts, right? So I will keep these switches separately for now because I want to prefer using the ones with those legs. So let's see how many there are. So 56 with, no, sorry, my mistake. So I have, right, 39 with legs and 43 without legs, which is okay. So I'll just start using the ones with legs first because they are going to be much easier for me to actually solder them in. Andrea says, I keep jumping between hobbies. One thing is common, you can read a lot, but nothing replaces getting your hands dirty. Absolutely, totally echo that. And one of the reasons back in the day I even did a lot of projects, this whole kind of habit of keeping your hands dirty, right? So once you get your hands dirty, it's very difficult to give up that habit, because there is a different level of satisfaction that comes from actually building things yourself. And you can't always do it, because like in this case, for example, parts can be a challenge sometimes, but just attempting to do these things also gives a lot of learning, particularly if you have interests in that kind of a project, or in that kind of a field. So yeah, makes a lot of sense. Okay, so let me try this out. So again, this is trying to fit in one switch with the legs. So I'm trying to figure out, yeah, so that's good. It's a good tight fit. And once you do this, so I'm planning to mount it as is, without any plate in the middle for now. I'm experimenting with it before committing to it. I wanted to make sure it will work. I mean, electrically it will work, but the whole effort will be at a different level, I think. So I'm looking for ideas on how to solder switches which are not having legs, because of course to solder switches I'll have to flip the PCB over, and guess what happens when I flip things over? Boom, the ones which don't have legs fall out. So I think these 39, 40 of them will be kind of just plug them in, flip it over, solder it. But the others, I'm wondering how I will go about it. So one thing I could do is just maybe use some adhesive of some sort. Let me see what chat says. There you go. Andrea says use masking tape. So yeah, makes sense. That's a good idea. Attach a row, slap masking tape on the row. Yeah, makes sense. So fit these in, tape it up, then flip over. They won't fall out. Solder them in. Yeah, that makes sense. And I think another challenge I see a little bit is just maintaining alignment. So I've seen keyboards which people have made where, not sure if this is focused yet. Yeah, there. So you see this rotation, right? So if I end up soldering it this way, the key itself will look very odd because it will be slightly rotated. So I need to make sure that they are in the fully aligned position, and it's not that one side is fully aligned. So there's somewhere in the middle where the alignment is right. So fully left rotated and fully right rotated are both out of alignment. Yeah, camera wouldn't focus that easily, but anyway. So I think the masking tape idea is good. I can align those things and then kind of tape it from maybe two sides so that the alignment also remains the same. Solder one leg, attach a keycap, melt joint, and adjust for alignment. That's a great idea. So what you're saying is it might be easier to just put one leg in place with a bit of a solder after. So put the switches in, put a masking tape, don't worry about alignment yet, flip it over, solder one leg of each little bit just to hold it there. Then attach keys and use the keys to do the alignment. Make sense? All switches must be soldered with one leg, and then switches must be put on. I can catch gaps well. Yeah, that makes sense. So in fact, you're right. So like take this keyboard for example. If anything was misaligned here, you would see this say U rotated a bit. And at this level, it's much easier to catch that misalignment than just with the switch. So yeah, it's a great tip. Got it. So get the alignment right with those, hold it in place, then reflow, resolder. Eyes can catch issues down to the micrometer. Yeah, that makes sense. And I saw it only when I think I saw it in Vim versus Emacs's top press switches keyboard, if I'm not wrong. I'll try and pull out the. Okay, let me see if that's still there. Where would it be? So RMK India. Yeah, I'm looking for the board where this rotation thing bothered me a little. And now how do I find? Oh, there you go. Thankfully, it has been pinned to the Reddit. Okay. There's one set, there's another set. Okay, I'm not sharing my screen. Rookie mistake. Right, so I'm just pulling up pictures from the keyboard meetup that we had in Bangalore. And there's one keyboard which I thought had this this issue of where are the keyboard pics? These ones are good. These, no, not this. Yeah, this one. Do you see it? The keys seem to be all rotated right a little bit. So I'm not sure why this particular keyboard has this issue. But yes, this did bother me a little, and I didn't want to get into this issue. So I'll try and be a little careful. And yeah, almost looks deliberate. Yeah, it's actually pretty regular. You're right. Yeah, maybe it is deliberate. So I mean, this is the best part, right? I mean, if you want rotated switches, you can get them because you are building the keyboard. So I mean, I think that's the best part about this kind of doing things on your own. You can do whatever you want, and there's nothing right or wrong. It's all preference. So that's the fun part of it. There's one key is counterclockwise. Yeah. You're right. One key is counterclockwise, and some are straight as well, I think. Yep. There you go. Yes. So this one seems to be aligned well. This one, yeah, maybe this is also aligned well. It's just an optical illusion. So yeah, I faintly remembered this keyboard having, like, I wanted to, so this was a top switch keyboard. I had not typed on one, and I was doing that, and instead of getting a feel for what the switches are like, I was like distracted by this misalignment more than that. So again, it's a visual issue. Not everybody is bothered with things like this also. So thought I'll try and be a little careful on my own, which sounds very famous last word-ish. I think I'm going to end up with some rotated keys, even with being very, very careful. So yeah, no worries. Okay, so chat catching up. It's aligned as well. If you solder it wrong orientation-wise, you will have interference with keycaps. In that case, it was a wrong way to solder. Yeah, that makes sense. Negative of negative is positive. Yeah, maybe. So one thing they say is, right, that two wrongs don't make a right. But if you think about it, three lefts do make a right. So the frames would be required to grenades. What? Okay, I missed the comment about World War II, and I was wondering where did we get to grenades. Interesting. It's skewed slightly. Yeah, Leopold is a great layout, and so there were a lot of these very, very interesting keyboards in this meetup. Right. So here is the Vortex cipher, right? And here it is now. Wait, how do I show it to you? Yeah, there you go. It's the same board. All right, and this is the Ergodox which we are trying to build. Right. So I think the finished output with what I have in mind will look very, very geeky, because it will just show the PCB and the switches on top and pretty much nothing. Maybe I'll do a foam cutout for the bottom just to protect it a little bit. So I'm trying to keep it as bare bones as possible. Just build it first. And so there's some interesting challenges, and I kind of need to take a very, very quick break, maybe a 2-minute break. I'll be back, and then after that we'll get started on mapping the pins between the Pro Micro and the Teensy. That seems to be an interesting one. So it'll either lead to some hand wiring, I'll try to minimize that, or hopefully mostly just pin remappings in Q&K. Yeah, there were a lot of interesting boards that day. Cool. So yeah, give me 2 minutes, folks. I'll be back. Stretch your legs, get a drink of water or whatever else you want to have. I'll be back. Okay, I'm back. So did the keyboard go boom? Oh, okay, I'm just catching up with chat. Yeah, that was a funny one. A good anecdote where people would straighten the... Yeah. Nice. Hey, thanks for dropping by, Zorbid. Yeah, it's getting a little late. It's 9 p.m. here. I was also wondering whether I'll do a dinner break or something like that. So one thing about the stream is I want to do at least 2 hours per week. Sunday evening, Sunday afternoon works out well for me, but I'm glad people joined, so it seems it might work out for people as well. So at least I'll continue this slot for a couple of weeks at least until the keyboard project is going on, and see where it goes from there. Cool. I still see some 5% frame drops, so not sure if that's affecting the stream, how much that is affecting it, but let's see. It's a learning experience anyway. Okay, so the next part of the project is Andrea says it seems fine. Cool, great. So what I did last time was I was streaming at 1080p, 30 hertz, 30 frames per second, and some people said that wasn't working very well with some of their devices. So I turned the actual resolution down to 720p this time, again at 30 fps, and I reduced the bit rate from 2.5 mbps to 2 mbps. So yeah, I'll see the VOD at the end of the day and figure out how well it works. So for the kind of things I'm doing right now, it's okay. I mean, the resolution doesn't matter. But when we get to things like coding a little bit, then like reading that text, it's more pleasant to see that in higher resolution. But one limitation Twitch has is for these occasional streams, I think for anything, unless you are an affiliate or a partner, or they have some criteria, so they don't do this on-the-fly transcoding, right? Because it takes a lot of resources at their end. At least that's how I understand it. So they don't do on-the-fly transcoding or even transcoding of the VODs to allow lower resolutions to be used. And that means whatever I stream at will be the only resolution available for people to consume at, for most part. So with that limitation, it's better to kind of match a kind of a comfortable spot where at least people can participate in whichever way they want. And another feedback I received was that some people were trying to watch the VOD on, say, a mobile network, and just having a high bit rate means sometimes the network wouldn't keep up and there would be a lot of buffering and so on. But I think if you're watching a video, it's still okay. Buffering a little bit occasionally is fine. But in a live stream, it makes sense to have to maintain interactivity more than just quality, because just pure resolution is okay when it's a choice, but if it becomes a burden, then it's too much. So yeah, cool. So next phase, let me quickly check. Right, so I talked about this a little bit last time. So we counted our switches. The PCBs have a particular okay, I should remember not to show a green PCB when I'm using a green screen, otherwise you get this. I'll switch to the side cam. Okay, Andrea says got to run now, friend has come over with the keyboard to fix. Awesome, nice. So enjoy your keyboard fix, Andrea, and thank you so much for stopping by, all of you. So it makes a lot of sense to have people here who know more about keyboards than I do. It's a great help. So yeah, please drop by next time as well. Yeah, thank you. Enjoy the rest of your evening. Zorbit says, what is this stream set to now? So right now it is set to a bitrate of 2 Mbps and 720p resolution at 30 frames per second. So let me know if it's kind of breaking or buffering or something like that. Okay, so this is where the IO expander is supposed to go, on the left hand side. Of course, these are just reversible PCBs, so the Teensy is supposed to go on this side here, right, on the right hand side of the PCB. And ultimately the two halves connect. Okay, let me get to a point where I can have both. I will adjust these lights a little bit because they are distracting. I tweak it a little bit later. Yeah, but for now, what I'm trying to say is just keep them here. To be gentle with the switches, don't want to bend anything. Right. Okay, so these two halves are connected via a cable that runs between them, and that cable can use 3 or 4 wires. So we'll get to the cable in some time. But the main point is one microcontroller here is actually scanning the entire matrix of keys via that connection, because it's a split keyboard ultimately. And if the keyboard was like this one, then there is no split, right? So physically the lines of the matrix, keyboard matrix, run all along, right? And so normal keyboards don't have this issue. But in a split keyboard, how do you split it? So common design that is use an IO expander, that is this chip, the MCP23018. What it does is it takes a serial kind of a connection and multiplexes it to give you more rows and columns, or data pins in this case. So although there are only 3 or 4 wires running between the two halves, it then allows you to read a lot more wires. I think it gives you some 24 pins of expanded space or something like that. I don't remember exactly. So let's say it gives you 16 pins, and those are enough to then seem like, so you essentially have those many virtual wires, and this is because it's a high frequency scanning kind of circuit. It all works out. So from the controller's point of view, it is able to scan these rows and these rows and columns of switches, right? However, since I don't have an IO expander, what I will be doing is taking one of these microcontrollers. One goes into the main microcontroller half, the other one goes to the other half, and kind of acts like how the hardware, the MCP23018 would in the first place. So it will do the multiplexing in software rather than hardware, but it's not hardwired to just do the IO expansion. So I have to flash firmware into that as well, because it's a microcontroller. It doesn't come with any software in it or any firmware in it. And the firmware I'll be using is the usual QMK firmware, which is open source and is commonly used across a large variety of custom boards. So the task I have is, so first of all, why this kind of a setup? Because I didn't find the Teensy, and it's expensive if you even get it. There are some clones available, but even I couldn't find the clones. And I could not find the this particular integrated circuit as well, the IO expander. Again, replacements are available, so I could have used a slightly different version, which is mostly pin compatible. But why do that when you can solve? Maybe it's a bit of my more recent focus on software speaking, but using a microcontroller to do this makes a lot more sense than being limited with a one-purpose integrated circuit, which it just leads to more headaches than it's necessary. Cool. So what's the objective of this part? The objective is, first, take the Teensy's pin diagram, right? So Teensy has these pins. The inner rows are for the microcontroller, the IO expander from the other side. So that's the thin one. So the two outer rows, right? So take the pin out of these two outer rows and try and map them to the pin out of this microcontroller. board. So this board is Pro Micro, Arduino Pro Micro, and that has the same internal microcontroller, the Atmel32U4, as the actual microcontroller that's supposed to be used here, which is the Teensy 2.0. So anyway, long story short, the brain is the same, but the body is a little different. So I have to adapt the pinouts so that I can actually use this microcontroller board in place of this as much as possible. There would be a few pins which wouldn't go because they are incompatible, and I will have to hand wire them. So they'll be like wires hanging off of the board rather than wires getting plugged into the PCB. Okay, so at least that's the part. And the reason I'm confident this is possible is because a lot of the derivative boards which were based on the Ergodox design have actually taken that route to get there. So they actually have these two microcontrollers. For instance, let me pull up, say Lily 58 is one design. Okay, let's share my screen first. And why is my video not visible? Okay, there. So the Lily 58 is another one of these split keyboards. And if you look closely at the picture, you can see that there are two microcontrollers here. Right? Here. It's a really neat design, much more minimal or reduced than the Ergodox. But there are two microcontrollers here. In fact, these are Pro Micros, the ones I have here, I think. And then there is this connecting cable, the coiled black one. It's what we usually call an audio cable, the kind that connects our headphones and microphones together, but ones with 4 pins. So 3 or 4 wires between the two halves, and then a USB cable that runs to the actual PC. Right? Now, my challenge here is because this board, the PCBs I have, was not designed for 2 microcontrollers, I'll have to hack it a little bit to make it work. But I have read reports of people who have successfully done that with this PCB. So that's proof by example, right? It can be done. Unfortunately, that person who did this maybe 3-4 years back didn't share their code or their actual designs or modifications that they did. They just wrote about it on a forum. So I will use that thread as a reference to learn whatever I can from there, but I will do this here and document it as much as possible and put it up on, in case somebody else wants to do something like this. Yeah, so learning experience, more adaptation, more fun. Cool. So let's get started. Let's start with the actual pin diagrams. So this is what the right. Okay, so this is what the pinout of the Arduino Pro Micro looks like. There are a few power or reset pins. These are the black ones here. So there is raw power. There are 3 ground pins. There is a reset pin and a VCC, which is plus 5 volt supply. Right. And one complication here is that these pins are not the same when you look at the Teensy. So let's pull up something for the Teensy as well. Okay, this one looks good. Disk Authority, that sounds nice. Why did I click in here? No idea. Back. Okay, so I just need this just to make sure it is, yeah. So this is from the original website, the pjrc.com Teensy pinout 2A. So these are our 2 reference items. Let me see if I can bring it out here. Split it out. This we don't need. Right here, split it out as well. Okay, nice. So we arrange it in a slightly different manner. Yeah, nope, that's not what I wanted. Yeah, that's what I want. So these two, and then here is our actual mapping. So I created an empty sheet just before the stream, and what I'm going to do here is maybe spend a bit of time. So yeah, again, help me out here if anybody is in chat. I'm hoping you're all out, maybe having dinner or something. But my goal here is take each of these pin numbers, see if so there are three things that would happen. We can use the pin as is without any changes, neither in hardware nor in software. I don't think that will happen for many pins. Might be a coincidence, but either we will have to use a separate hardware line, for example, raw power on the top right, and raw power on the top and VCC on the top right. So actually it can work because I can still supply VCC, which is 5 volts in the raw power input, and it will just go through some conditioning circuit again. So it might work to just use this power here, but the top left pin here is ground, and the top left pin here is TX, not ground. So this pin, for example, I cannot solder directly into the same spot as the actual PCB. So I will have to route it somewhere else. So there will be a wire going from here to the actual ground pin, which is here. Right? So it will be like a jumper or some sort of arrangement, but hand wiring. However, most of the other pins, right, like take the bottom left pin, for example. This is PC7, or as it is called. Okay, I'm missing I think I'm looking at the wrong nomenclature here, so I won't find the names corresponding. Let me look for a better pinout. I think there is one somewhere. Yeah, so this is the one I really need. I want it to be rotated this way, which I can do. This works as well. No, this is the one I'm using. That doesn't work. Okay. No. Yeah, so the A are here. This corresponds here. Then the A's and... Okay, I think this might work. Okay. It is the Teensy 2.0, I hope. Yeah, that is one of the issues. Nope. I opened a Teensy 3 pinout. Okay. plus. So what I'm looking for is a Teensy pinout which actually uses these names, which QMK and so on use, so that I can actually see the names. But if they're talking in different languages, I can't even correspond them to each other, right? So this says like PF7, PB6, so, and this doesn't use that terminology here. So how do I connect from here to here? I think, okay, I have seen one of these. Let me just search for a quick while. This is Teensy 3. So I'm looking for the Arduino names. Right, I think this looks like it. Okay, sounds encouraging. Let me look at the actual page to make sure it is. Yeah, Teensy 2.0, which is fine. Oh wow. Yeah, so this page is about Teensy 2.0. I don't know where the picture comes from, but let's see. Here. Okay, so this looks better. So what I was looking for was these names, A0, A6, and this is A0, this is A10, A6. So you can see that this is the one on the top is the Teensy. Wait, isn't it the same? Oh, okay, 2A, 2B. So it was lying next to it. That's fine. So we don't need this diagram, which uses the other set of names. We need this diagram, which is the Arduino names, which are also used in this diagram below. So on the top right is Teensy 2.0, and on the bottom right is the Arduino Pro Micro, which I actually have. And our exercise is to take this pin out, which is what the PCB is designed for, and map it to the actual pins in this PCB or in this board, which is what we'll be actually using. And we'll see how far we can get with software remapping or hardware rerouting. All right, time to get started. So what I will do is I will draw this and mark this here. I mean, just using a spreadsheet because spreadsheets, but otherwise you can use anything. Right, so how many pins? 12 pins, right? 12 and then another 12. 1, 2, 3, 4, 6. Yeah, so 10 plus 2, 12, right? So we'll go with that. I do want a pin number, which I'm used to from my past life. So I want that. So 1, 2, 3. So these are pin numbers. Then the board in the middle, and we will have the names on the outer side. And so these will be then 13, 14 and back, I think it can fill up as well. Right, so these are the 24 pins. I will align this on the left. Right. So this thing in the middle is our actual board, and we won't have to say much there. So I'll just merge these cells. Yeah. Okay. Looks like an integrated circuit already. Right. Nice. Cool. So this is something I used to do earlier, so I'm a little bit more familiar with this than but I do want to explain things if something isn't obvious or is a little harder to understand. So if anybody is in chat, just feel free to ask questions or have suggestions, because I haven't actually done this in a very long time, and we are doing something which is not straightforward, in the sense of it's not like something which is documented somewhere. So if there are any gotchas, like incompatibilities between these two microcontrollers, even though the names are the same, we will have to read them. So this is just like a first activity. Before I actually touch the hardware, I will have to go back and check the manuals for each of these to see if they're actually compatible. And I do have a few references where people have interchanged these, so I would be able to learn from their experience in that sense. Okay, so what all do we need to know? So we need to know the PCB name, PCB pin assignment. Okay, so that will be this one. Okay, and what else? Okay, that's just fine. So we will use the PCB Teensy 2 pins as the first layer, which is from the PCB's point of view, and we need to map it to the Pro Micro's pins, right? So I'm going to change up the music a little bit. Yeah, Luberman. Yeah, spreadsheets, right? So very versatile tool. I use them as pen and paper most of the time. But yeah. I have used spreadsheets for some very weird uses. There was a friend who designed a t-shirt in a spreadsheet. So they actually resized the whole sheet to be square cells, and then just filled them with the color to make a checkerboard pattern of, a multicolored checkerboard pattern. It was, I think, one of the most unusual use of a spreadsheet I've seen. And imagine what the t-shirt printing vendor thought of it when somebody sent them an Excel file saying print this on a t-shirt, and this guy was like, what? So yeah, correct, you're right. But grids help. So yeah, spreadsheets are just grids. So yeah, maybe I'll try wearing that t-shirt next time, for the next stream. So yeah, it'll be fun. Cool, let's get this done. So first thing is to just copy the things from the Teensy, and we'll just verify that the PCB also, we don't need to do that. The PCB is built for the Teensy, so we'll assume that the PCB and this diagram are compatible. I will check that offline before I actually solder anything. One quick note is that the Teensy does have these internal pins, F5, E6, and these side pins. Thankfully, the Ergodox does not use these, so we don't have to worry about them. We just have to talk about the 24 outer pins, and those are available in a slightly different arrangement on the Pro Micro. As you can see, the Pro Micro, we'll have to count how many does it have, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So we have the same number of pins in both. So physically the two should fit into the same place, but of course logically the pins mean things different, and hence the mapping. Cool, so let me just quickly write this out. So this is ground, this is what? Okay, this 0 doesn't help. What I want to know is what is this actual pin? Okay, I think I need another layer. So this column is just for my convenience. This is what Teensy calls it. Maybe I'll just make this a different color so that not to distract ourselves from this. Yeah, that's good. So these are the actual numbers we want to use. Right, so this goes down till 10 and then 11 upwards, right? Yeah, so again, insert one right. Boom. Okay, so this is just called plus 5 volts. What? Spreadsheets. How do I do this? Tick plus 5 volt, right? Yes. Okay. This is essentially what the Teensy calls it, but Teensy has these other names, the A0s, A1s. Those are the ones I really need. So these are the Teensy numbers. I don't know why they just don't number it serially in this diagram. What's the point of having ground and then 0 and so on? But it's okay. It's what they call it. Right. So the ones we are really interested in are these A0, A1, A2. So let's get those down first. Till A10. Any gaps? I mean, sometimes, this is a board, so it should be okay. People will do something, but sometimes to save a jump on the PCB, people use different orderings, right? So after A3, it might be A5 and then A4. So one has to be really careful while reading these, or or you don't do it and then you use it in a circuit and you figure out later that you misread the datasheet. So yeah, I think I've been bitten enough times by this to actually go back and check what these are right now. But that's fine. So it's okay to, so the interior ones we don't care about, and the LED on 11 is fine. So these are the ones which we will need to map here anyway. We'll come back to what these interrupt pins are and which ones we need, because that's a little harder to read from here also. Okay, no problem. And the PWM and all are marked as ticks. So one thing I'm thinking of doing is actually adding some backlight to the ergodox. Again, ambitious thought, because the original PCB doesn't have backlights or any LEDs at all, except for these indicator LEDs, which are, I mean, they're not here, but they're in the original design, these 3 indicator LEDs. Right, and if you go down here, you can see them being soldered as well in one of the guides. But anyway, so indicator LEDs apart, if there is a PWM pin left, I will use that to just control the brightness of a bank of LEDs. So just a simple underglow kind of a thing. I have some LED strips which I will mount and just use these PWM pins to control brightness, and we'll see how that goes. I'll need some sort of an LED driver circuit, but I'll add that later, not now. So let's see if we can leave one of the PWM pins empty on the Pro Micro, because that way we'll be able to use that one for the backlight. And PWM, in case anybody is wondering, is pulse width modulation. It's the way we use a single voltage level, let's say 5 volts. But if you want to vary the brightness of an LED connected there, you just turn it on and off really fast. And if it's on half the time, off half the time, then it's at 50% brightness. If it's on all the time, it's at 100% brightness, and so on. So that's what pulse width modulation gives us. But you need a pin that is able to do PWM, as far as I can understand. So you can't arbitrarily use any pin for that. So certain pins can be configured as PWM and you want to leave one of them empty. Cool. So Luberman says you can use Easy EDA. It has an online client that will make the work easy. Yes. So I've used a bunch of these earlier, but maybe what I'll do is during the week, I will go through like a small, quick 10-minute hello world of one of these tools. And it's good to know that it has an online client that will make it much simpler. And so maybe from next stream onwards, we'll use a proper EDA tool rather than spreadsheets. But it's kind of fun, right? Like, using something for something it wasn't designed for is actually the definition of a hack, right? So a hack is using something which is designed for X for purpose Y. So yeah. Anyway, let's continue. So okay, INT 0123 is fine. I'll write it out here. 5 is INT 0. Okay, 1 to 3. Having the alignment okay is visually easy on the eye. And these are PWMs. Okay, I think we have what we need from the Teensy circuit. Now let's see if I can find the corresponding. So we will be writing the corresponding Pro Micro pin number, and so we'll have to write the pin name and then the pin number. So what I'm calling pin numbers is physical pin numbers, right? Because this is essentially what you ultimately solder. And really, from just working with lots of integrated circuits in the time back in the day, you just follow this U pattern. You start at the top left with 1 and then go around. So this is something I'm familiar with. It's software uses these logical names, so the pin numbers don't matter, but we are doing changes on the physical pin level. So this physical pin number is useful for us. Right. Okay, so Pro Micro pin is the name, right? So this is the pin name and then pin number, right? So okay, I need that on this side as well. All right, let's see. Sometimes it might call it something different. So I think here the Pro Micro is calling it A0, A1, A2, A3, A10. So the names don't change. So you can just copy these for now. I think it's probably a useless layer, but let's check that anyway, because I don't see the INT pins being used here as these names. So there might be some name mapping also needed. Just useful to have this reference for maybe say a blog post or something for somebody else who might be doing this. We need to go from physical number to physical number ultimately. Right. So where is A0 on the Pro Micro? It's pin number. Okay, so here is the funny part. What are these numbers now? 1, 0, 2, 3, 4. See, 1 and 0. 0 and 1. 2 grounds, and so numbers get skipped. So we need this layer as well. Oh man, so many layers. Okay, let me add it. Okay, let me first find the pins for these A0 to A10. At least that should be one thing done. So A0 is on 18, which is physical. So this is Pro Micro physical pin. Okay, that's ultimately what we want. And what did we call this? Pro Micro pin number. So it has a pin number, or I think it's maybe a label or something. So that's okay. Now I understand what's happening. Maybe what they have done is they have numbered these after the microcontroller pins. That might be it. Cool. Anyway, so we'll get there. So A0 here is 18 here, and physically it would be what is this? 1, 2, 3, 4, 5, 5th from the bottom. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 17. So pin number 17 is pin number 18. You see there, you see why we need all these layers. So physically, let's double count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 on one side. 13, 14, 15, 16, 17. Okay, yeah. So this is pin number physically 17, called A0 helpfully here on the Pro Micro board itself. So we don't have to remember this. And it's logical number 18. So we wrote that Pro Micro pin label, I'm going to call it, because the number terminology is a little weird. Teensy label. Pro Micro label. All right. So we have name, label, and number. Right. That makes sense. What? So the Teensy name and Pro Micro name should mostly be the same, but because this is essentially what we will use inside QMK also to map it or remap it if needed. So the idea is, for most part, we may not need to change this, so there are two levels in this mapping. One is how many pins are in the same place as other data pins. So the Pro Micro name here is actually a misnomer. Let me, okay, so this is actually incorrect. So what we want to do here is, let me leave this for now. So here is the point. Actually, good. I'm glad I noticed it now, otherwise I have to undo it. So what do we want to do? We want to use this pin 23 in the Pro Micro for something else. So this forward mapping we are doing is of limited use, right? What we want to do is we want to go between the Teensy name, which is A0, and figure out if we are going to use another pin in place of A0. So on place 23, which is here, we have ground. So we can't use anything in place of A0 because according to the PCB, it is A0. So it is using it as a data pin. But in the new microcontroller, it's going to be ground pin, right? So we can't use this. So in the Pro Micro's case, we have to use a replacement for A0. Okay, and so this is one of the few things which we can't. So what we'll do is, I'll take a wire from the PCB from pin or location 23 on the PCB and route it to something else, right? So it's not physically in the same place, but there is a wire going from say here to here. So yes, I can route it to the actual A0, which would mean that we don't have to change it in software. So if the A0 of the Teensy is in pin 23 and the A0 of the Pro Micro is in pin 17, then we want to run a wire from 23's location on the PCB to 17 location on the microcontroller board. Yeah, that's right. And how do I designate that here? So Pro Micro name is the same, of course, in this case. Yes, so this will remain A0 because we can't run it in here anyway. And I'll add a type here, mapping type. So mapping type will be handwire. Okay, so here is how we read this. We don't need what the Pro Micro's 23 pin is. That doesn't matter because that's something we are reading right now. What we want to map to is where does it go on the Pro Micro? Where does this pin, location 23, physical location 23, where does it go on the Pro Micro? Good. So we have mapped it logically to the same pin, same logical name, port pin name on the Pro Micro, and ignore the label for now. Okay, yeah, the label is 18, which is right, and the Pro Micro physical pin is 17. So that's how we come to this mapping. Because it is a hand wire, we are going from 23 to hand wire it to 17. So there'll be a wire running from 23 to 17. All right. Next, let's see. Let's knock out some of the obvious ones. So pin 24 is plus 5 volt here, is raw power here. So the Teensy name is the same. Pro Micro name is just raw. Sorry, the Pro Micro label is raw, and we are going to retain it as is. So I can actually use a header here. So header means there'll be a physical pin just going from the controller down into the PCB. So this is on the assumption that I can actually supply a 5 volt raw and it will still work. It's technically supposed to go to VCC as well. So I will have to either do this or hand wire it. So I'll add a note to check if raw equal to volt is okay. I think it is okay. The raw power can be, I think, even higher, up to I think 12 volts or something like that. So internally the Pro Micro has this conditioning circuit which will condition the raw power that you give it. So for example, you could run it off a 9 volt battery which isn't 5 volts, but the Pro Micro will then condition it down to 5 volts and use that. So if you're connecting raw, I think you should not connect VCC. That's what I remember reading, but I'll check that again. All right. Where do we go next? Just thinking. Maybe let's continue down this left side, okay, and can be a little smaller, I think. Yep. Nice. So yeah, if there are any questions, just feel free to keep asking them. Questions help understand the process better. This isn't a standard process I'm following. It's just thinking aloud and doing this work. But I still want to go through with it because these are the constraints, right? So having people ask questions about why you're doing this, why you're doing that, explaining it helps me understand what I'm doing better as well. So yeah, please do ask questions if you, or suggestions if you have of doing this in a much simpler way. Anyway, I'll continue. So pin 22, let's read down. So third pin from top is A1. And for here it is RST. So that doesn't work. I cannot connect this pin of the Pro Micro in as a header. So this will be another remapped one. So again, let's take A1. Is A1 available here? It is available. So let's take it directly to A1. I want to minimize hand wiring, but anyway, we have to do this. Pro Micro label for A1 is 19. And the physical pin number, I think, is 18. So this was 17. So this will be 18. Yes. Just double check. 13, 14, 15, 16, 17, 18. That's right. And again, this is hand wire. Next. So the one below A1 is A2. And that is VCC. So that again cannot be used. So we'll take it to A2. A2 is available. It is. Okay, so this is 20. Pro Micro label is 20 for A2. And it is physical pin number 19. And I have to hand wire it. Come on, less hand wiring, please. I think these are the problem spots where you have raw, ground, reset, and VCC. These are the ones which cannot be mapped. I think below this, we will start seeing some mappings coming up. More like software mappings. This is not a software mapping because it's just power, right? So nothing to change in software. Okay, down to pin number. So 1, 2, 3, 4, 5th from the top is 1, 2, 3, 4, 5, A3. So yeah, 2018 is A3, that's right. And where do we map it to? So what is 5th from the top? 1, 2, 3, 4, 5. It is A3, awesome. But it's called 21 here for whatever reason. Is this right? So this is a lucky break. Physical pin 20 on the Teensy is designated A3 name. Let me count from the bottom this time. So this is 13, 14, 15, 16, 17, 18, 19, 20. Yes, so physical pin 20 is 18A3, and 13, 14, 15, 16, 17, 18, 19, 20. Physical pin 20 designated number 21 is A3. Awesome. Physical pin 20 designated 21 is A3. Wow, that's a lucky break in the sense that I don't have to do anything here. No software change, no hand wiring, just add a header. Awesome. Let's go. Next. Yeah, luck will run out pretty soon. So this is A3. The next one down is 17A4, and A4 isn't here. Where is A4? Are you kidding me? I don't see an A4 here at all. Seriously? Or am I blind? A0, A1, A2, A3, no 4, no 5. Okay, so I think these might be internally not connected, or okay, yeah, I remember reading that in the Pro Micro you can use this RX and TX LEDs as 2 pins, so maybe it's those. I'll have to check that. So we don't have A4 at all in the Pro Micro. NC being not connected. So we don't know. It seems it's not connected, so it's not on any pin. So what do we do? We will need a replacement for this. So I will have to look for some other pin, some other data pin, which I can use in place of A3, A4. Okay, so this is TBD. And this will need to be a software mapping, or let's say firmware. It's firmware enough. But I will have to find out what this is. We'll come back to this. So we'll identify all of these and then do it at one shot, because pretty much we have to pick a pin which is available on the Pro Micro. All right. 16A5, 1816A5, 16A5, where is A5? A5 is also missing, so we can't map it to A5, so we have to figure out. Great. No problem. 1715A6, 15A6 is a PWM pin. Where is A6? So A6 is on pin 4. So I have two options. I either route it to pin 4 with a hand wire, or I can just check what is here, and if it's a data pin, then use that. So here is the kind of reason I'll have to keep editing this sheet. So I have two options all the time, right? I can actually hand wire everything, like take it to the correct pin inside the new controller. That would mean I don't do anything in software, but changes in software are cleaner and changes in hardware are messy. So I want to prefer software solutions. So even these hand wires, if they get used, for example, they are getting used right now. So physical pin 17, we have just used to connect A0. Okay. Now we have two options here. Either we can let that remain and take this to something else, which is A6, which will be another pin, so going around. Instead, I want to check if I can go to whatever is, so as far as possible, I want to plug this physical pin 17 into whatever is pin 17 on the Pro Micro. That way I can run a header. And in this case, let's see what is on pin 17. We know it is A0. So if I remap A6 to A0, A6 in the Teensy being A0 in the Pro Micro, and do that remapping in software or in firmware, in the QMK firmware, then I can just run a header through. So let's just try that for a second. Okay, so how do I do this? Strike through, and so instead of running this to A6, Pro Micro name, don't care. Pro Micro label A0. Okay, no, so hold on. So let's map this to A0. It's not don't care. Raw 18, 17. Okay, and this means I can run a header. So ultimately, I want as many headers here as possible. Header is just this, this thing. Not sure it's visible. This vertical thing that runs up and down. In case you can see it, it's just a single straight connector. So as many of the straight connectors I have, I can just drop the lines here, no messy rewiring, and only software changes. Software changes are okay because I just rewrite one header file once and it's done, right? So let's prefer these. So far we hadn't encountered this now, which means we have to find a replacement for A0, and A0 can't be a straight through because it's ground here. So there is no mapping through headers possible. But let's continue. 14A7, 14A7 here is fourth from the bottom. Fourth from the bottom is 15S clock. What is that? Can I use this? I don't think so. I think that one thing I'm missing is, so TX, RX are here, but where are these S clock, MISO and MOSI pins in this diagram? I'll have to read up and figure out, but for now, let's skip this. So we don't know what we'll do with this. So is there an option to just use A7? Yes, we can. So let's write that down at least. What we can do is we can run it to A7 on the Pro Micro, which raw pin number is is what? A7 is 4th from the bottom here, so 4th from the bottom here is 7. Sorry, 9. So raw pin number 9, right? Yes, so raw pin number 9. So 6 and A7 on the Pro Micro label is 6. Physical pin number is 9. Correct. 6 is pin number 9. Sorry. 6 is pin number 9. What did I do here? No, not that. Okay, we don't have these layers there, no problem. 9 is 4th from the bottom and 9 is 4th from the bottom. Yeah, that's right. So we can run it to physical pin number 9, which will become A7, and then it will be a hand wire. We'll come around to see if this needs to. So we'll do first pass with this, the most obvious solution, and then mark out things which we have reused in preference for headers, and then come back to see if we can remap the others into the hand wire to header conversion as well. Cool. And I realize sometimes you can't see this because my head is over it. Can you just switch these? Yep, there. I think this is better. Yeah, these kind of small things just let me know if it's something is obstructing something, and I can, like, I'm not watching my own stream too much, so sometimes I don't notice these things happening. But yeah, this is just as good. All right, so 3rd from bottom is A8, 13 A8, that's right. And what is in this place? It's a meso pin, so I don't know what's, I'll have to check about these 3. But let's see if for now we can write down the hand wire part. Where is A8? It is on the 2nd pin from the bottom, which is physical number 11. And that is 8. So this is, can go to A8, which is raw pin number, sorry, label 8 and physical pin number, what was it? What did I find out here? 10. Awesome. And if we do this, it's a hand wire. Hand wire seems to be winning, but we'll come back to it. 2nd from the bottom is 12A9, which is this. So let's find A9. It is the last pin here, which is pin 12. So pin 12 is 9A9. Okay, so this is A9, 9 and 12. Hand wire done. For now, last pin here is 11A10, and this is A10 as well. Awesome. So although it is called 10 internally, for whatever reason, it's actually physical pin number 11, and hence when the two match, it's a header. I realize I can set this column directly to make sure whenever it is header, it means that the physical pins are the same. Yes, that's how we should go, but that's fine. Okay, so one side is good. I have this urge to still press Ctrl S sometimes to save the spreadsheet. Old habits die hard. This is Google Docs, so you don't need to save anything. Cool. So I need to just power through this for some time, and let me know if there people are still around. What do you feel about what is happening, and is this too complicated? I think it's a little bit too complicated. I would love to just get a Teensy 2.0, drop in there, get a IO expander, drop it in there. But it's okay. We have to make do with whatever we have. Maybe in the next build I'll try to get more of the vanilla hardware so that we don't have to jump through these hoops. But for now, this seems to be working well enough. Let's see where it goes. All right, so let's mirror this here. Teensy label. This is 10, add one left, which is Teensy name. This is Pro Micro name. Pro Micro label, Pro Micro physical pin. You need lots. Okay. Right, what do we have? Pro Micro label, physical pin, mapping type, not. All right, name, label, physical pin, name, label, physical pin, mapping type, not. Okay. Okay, I think the sheet is set up. What am I doing? Nope. All right, so let's see what is on pin 10. Pin 10 seems to be PWM. Is it even used in the circuit? So yes, PWM pins are used in the circuit. So I need to check whether it's actually used in the PCB or not. So we have the Teensy names, but like, is it used? And since I don't have these, I think I'm a little stuck here, right? So I have to figure out what these are, and if any of these pins are actually connected on. So for instance, there are these internal names, right? So for example, these A names are, so A7 is B5, A6 is B6, A5 is F7. And internally here, we don't have that external nomenclature. So we're trying to jump through these A names, which we just ran through. And we didn't find A4 and A5. So I need to now check which of these, like what is their equivalent nomenclature in this part. So I need like a reverse mapping. What is D0 in Arduino terminology? We search for that mapping. These are developer excuses which come up from the browser. Teensy 2.0. What the heck? I'm not able to type today. I should have searched for this earlier. Not this. I remember seeing. Not this. Interesting. The additional pins are B0 and D5 as described in the datasheet. Has even OG pins which could be available. Something that's not ready for beginners. I should have just looked for this. Right. So Arduino makes it confusing by not mapping its pin numbers to AVR ports. But this is for a reason. Some pins on the AVR can also be used for special purposes such as serial, timer, PWM, and they are therefore sometimes labeled by those functions on the Pro Micro. Here is the mapping. It says this jumper is close to, okay, this is the jumper part. So raw power, so raw power has to be 6 volts to 12 volts, at least according to this guide. Let me just bookmark this for now. Right. So according to this, it is using, right. So these are the D names, these are the A names. and we ran out of, where are A4 and A5? A4 and A5 aren't present, is it? Looks like it. So we can look for these B names in the other part, and then we can check. Okay, no problem. So I think this is very useful. So why? Because this presents the Pro Micro side picture. What this is saying is, if you look at it from the Pro Micro's point of view, essentially the reverse picture that we were drawing, here are the pins equivalent on the Teensy, and hence you can figure out what's happening. So let's see what this is. Let me read through. If you use QMK, hold on. So if you use QMK, which we will be, you will have to translate the pin names marked on the Pro Micro PCB to the AVR ones. Example, pin 3 on the Pro Micro is called D0 on the controller, which is fine. Arduino makes it confusing by not mapping its pin numbers to AVR ports, but that is for a reason, as it said. And here is the mapping between those two. Okay, so what we need to map to is pin 3 on the Pro Micro is called D0 on the controller, and QMK uses controller names, as far as I can understand from here. So pin 3 on the Pro Micro is D0. Where is D0? Yeah. So this pin 3 on the Pro Micro is physically this pin labeled 3. And this is a little different, isn't it? Yeah. So TX0, TX1. Let's just compare this to our what? Awesome. This is cool. Yes, so let's compare this to what we have so far. Yeah, I mean the one below here. Yeah, so TXRX, yeah, so this and the designation internally is fine. So they have eliminated this level. Right, awesome. So D0 is pin 3. Pin 3 here is D0. Okay. That's the level of detail not available here, right? So if something was called D0 here, we can hopefully look for D0 in this pinout. Not here, here, right? It is on what is called pin 5 here. Awesome. That's cool. That's cool. So isn't all right. Okay, now I understand. So what they have given in that D0, B1, B2 layer is are these, is it? Teensy labels, ground, B0, B1, B2. Let's check that. Ground, what? No. Awesome. So maybe what we are seeing here is the common label D0. So let's see where D0 lies on each of the boards. So on the Teensy, not Teensy, on the Pro Micro, both of these are Pro Micros, slightly different views. On the Pro Micro, it is pin labeled 3, all right, and number 1, 2, 3, 4, 5, 6 from the top, right? 1, 2, 3, 4, 5, 6 from the top. And if you switch here, 1, 2, 3, 4, 5, 6 from the top, right? So that's the difference. What is D0 in Pro Micro is B7, that's same physical location in the Teensy. But my point is, if we use this internal terminology, which is not visible on this diagram, but is labeled on the Teensy here internally, this D0 nomenclature, we can just find the mappings and choose those pins to be our targets for this. So essentially, where should D0 go? It should go wherever either D0 is if I'm hand wiring, and that's a start. Okay, awesome. Hey Lieberman, you're going to have dinner. I am also hungry. I didn't anticipate this will take so long. So I will do one pass with this internal terminology part, and maybe then I'll call it a day. So yeah, go ahead, have a nice dinner. If I'm around streaming when you get back, I'll see you again. Otherwise, take care. Thanks for dropping by. All right. So continuing on, let's see how far we get with this approach. And again, this is just a matter of logical names to physical names to software or firmware names, right? So there are like 2-3 different universes that are colliding here, and hence it becomes a little bit complicated. But let's not lose hope, but we'll continue. Just as an example, one layer which we have not noted here are these internal names. So VCC, F0, F1, F4, F5. So we should note these. So what is it if it's not the Teensy label? Teensy number. Teensy label. Let's call the internal labels as Teensy labels. It is VCC, right? So VCC is 5 volts. This is F0. This is F1. Then F4. Then F5. If I can read correctly, is this F5? Yes. F6, F7. What? Typing on image. F6, F7. So F7 is where A5 is, right? F7 is where A5 is. A6 is B6, B5, B4. Okay. B6, B5, B4. All right. D7, D6. Awesome. Right. So, I mean, I don't know what these are officially called, but I'm calling the internal white labels as Teensy label. The Teensy name is what is outside here. The Teensy logical number is here. Right, so maybe I'll just move this here. Oh, come on. There. Okay, why I did this was because then it's in the same order. So Teensy label, Teensy logical number, Teensy name, Pro Micro name. So beyond that, it's mapping. All right, and let's write this for this as well on this side. So physical, then Teensy label. So one left here. This spreadsheet is becoming a very wide spreadsheet. Maybe it's a better idea to do this. I think it can work. How about this? Yes, I think this works. But why can't I resize this? Okay, fine. Wait, resize one and then just up down. That makes sense. Perfect. Okay. Good. Yeah, good enough. I'll just get some more space by this. Cool. Okay. Yeah, quick adjustment. Physical number label, logical number, and Teensy name. So where is int0? That is in the same thing as a. That is Teensy name. This is Teensy name. What is this? Teensy label is the internal label. This is Teensy, so this is actually Teensy logical number. Okay. Did we get it? Right, physical number, label, logical number, name. There are two Teensy name columns now. There. Okay, I think this is fine. Yeah, let me write down the labels for the remaining ones. We are skipping the side pins. So pin 12 is C7. C7, C6, D3, D2, D1, D0. Wait a minute. Right. Yes, B7, B3. B2, B1, B0 ground. Okay. B2, B1, B0. Oops, what am I doing? Nice. So this is Teensy. All right. Okay. So now that we have all this, cool. This is all right line. To mirror everything nicely. There. Okay, so I think we have this set out correctly. Yeah, and I'm not writing the PWM designations here, so that's fine. I think Teensy part is complete. Now, what we can also use this layer to now map to the Pro Micro, because in the Pro Micro we have. We don't have it in this view, but if I go down to this other view, this did have the numbers for the Pro Micro. Let me just make sure I have read it correctly. Example pin 3 on the Pro Micro is called D0 on the Atmega 32U4. So the D, C, B, E, F designation are actually the Atmega 32U4 chip pins. So if I were to open up the data sheet for 32U4, which I should do, I would see these names. I hope so. Why is it referring to 16U4 data sheet? Okay, they are the same data sheet. That's fine. Makes sense. This happens often. Manufacturers publish one data sheet for 2 chips, so that's okay. Right, and yes, I'm just trying to, where the heck is the, how do I make it fit with? Yep. All right. What I'm looking for is, yes, pin configurations of 32U4, 16U4. Good. They're the same. Yes, so this is the actual chip, and here what you see are these C6, E6, PB2, PB5, PB7, that designation. Good, so this is a useful mapping to have available. Don't need to take it to the spreadsheet, but we can go by this because this chip is the thing which is the same in both of these microcontroller boards, the Atmega 32U4. Fine. Nice. Cool. Okay, so I'll read this again offline. What I want to finish before I end the stream is just run through this a little bit and see where we are at. Okay, yeah, so we have all of these other designations here on the first pinout. So yes, I forgot we had opened that. Cool. This is good. This is helpful. Let's just quickly make sure these are the same that we have captured. So reading from left down below is B0, B1, sorry, ground B0, B1, B2, B3, B7, D0, D1, D2, D3, C6, C7 side pins, skip them, D6, D7, B4, B5, B6, F7, F6, F5, F4, F1, F0 and VCC. All right, so this checks out. We have all of this, and thankfully we also have this MISO MOSI S clock designation on this view as well as on the Pro Micro view, so we can do that. I don't think we can change these designations, so I'll have to just hand wire these. Let's see where those goes. So what we have to hand wire is these three pins: S clock, MOSI and MISO, right, on the Pro Micro, which are here. So they have to be directly hand wired to their corresponding designated pins on the Teensy. So this is Teensy pin numbers. Right, so this other diagram had missed out those things. So let me complete that. So these are all the Teensy names, right? So let's complete this. Ground doesn't have a name. Pin number 2 is SS, SCLK. I think we're getting there. MISO. All right, what is it? OC, OA, RTS. RTS. OC1C, OC0A. That's what this is called. Okay, this is OC0B, SCL, and interrupt 0. Then this is called SDA, and this SDA91, RxD1. I can understand if somebody jumps into my stream right now, they'll be like, what gibberish is this fellow spouting, right? Like what are these acronyms? I also don't know. They mean something, but I've not gone down to the level of what they are. Just try to do the mapping correctly for once, and then dig deeper into figuring out what they are if we need that information. RxD1, 93 is TXD1. So people who are familiar with the Atmel, the Atmega 32U4 would understand what these mean, and people who are familiar with microcontrollers in general may find this terminology easy to follow. I'm not that familiar with microcontrollers, but I've used a bunch of them in projects. And I've used microprocessors a lot, 8085 and all, back in the day, like 20 years ago. There is a certain common nomenclature, like INT is short form for interrupt. So if you have interrupts coming in from sensors and so on, other inputs, you would connect them to these pins because you can use them as interrupt pins. So those capabilities are selectable between, internally in the microcontroller. And this was not the case with microprocessors, because you're just sending instructions to a microprocessor. You're not really changing the internal firmware, whereas in microcontrollers you tend to program the behavior of the pins, and in general microcontrollers today are way more flexible than microprocessors were back when I used to work on these things. So yeah, there is some understanding gap which I'll try to close if needed. I mean, it's not really essential to use these things, particularly because we have good guides available. But the kind of work I'm doing right now is a little bit off the charts. It's not standard, so you have to do this kind of weird stuff. So OC4A, OC3A, then pin 10 is... oh, it's OC4A bar, okay. So I designate that with underscore because bar is a little difficult to put in here. So OC4, so this bar terminology is usually an invert signal. So if you configure this as OC4A pin, then both OC4A invert and OC4A are available, it seems. Not sure why we need to know all this right now, but for mapping we might find this useful. I don't want to refer back to this sheet, these images, after we have all the information in the sheet, because the optimization of the routing will happen in the sheet. Right, I think we have all of these, and on the other side, why am I missing something here? Oh, so this is the internal nomenclature, the Teensy name. There's one more layer here, isn't it? Oh boy. No worries, it's okay. So D6 is ADC9. So ADC is a analog to digital converter. So ADC pins are helpful because if you convert an analog, connect an analog sensor like a temperature sensor, it just gives a varying voltage, and you need a ADC pin to then convert that analog signal into a digital signal, say a level of or a readout of a number between 0 and 255, let's say, which indicates what temperature you have. So these ADC pins are very useful because here is where you will connect all your sensors. Just that the naming is a little different between these parallel nomenclatures. So I think we can skip this, but I'll just do it for completion anyway. ADC9 T1 OC4D underscore. Then this is ADC10 T0 OC4D. Right, ADC11 ADC12 OC1A OC4B underscore. You might be wondering why there are so many parallel nomenclatures. Usually you have to use only one of them, but in different applications there is one set of names from the chip, there is another set of names from the board, and there's another set of names from the other board, and thankfully the chip is the same. So we could have been changing chips as well. So if you're going from 32U4 to say something like 328 Arduino, then the names on the other side will be different as well, and it adds complication or complexity to this whole system, but we have to deal with that. Right, I just noticed that I was covering part of the picture. Right, let's continue. Right, I don't need this row. Good. Right, and let's just continue this. So ADC 12, so ADC 13, where am I typing? OC1B, OC4B. Okay, now the rest are simple. This is just ADC 7. What's happening here? Hey, mediocre pudding. Hi, pudding back. I'm just actually about to finish up. There are so many parallel nomenclatures of these pins. I'm just adding all of them to the sheet. I found mappings for one half of the Teensy to Pro Micro controllers, and just finishing off the rest of the half. And with this, I'll have a full plan of whether I have to hardware, either hand wire a pin, or I have to just put a header in, or I have to remap it in QMK firmware. So just noting these nomenclatures down, ADC6. So we entered a situation where the two diagrams didn't have the common names. So I'm just trying to bring everything, all the parallel naming schemes into one sheet. ADC4, ADC1, and ADC0. All right, yeah, good to have people around to talk to. It's always helpful. Otherwise, it's just me speaking into nothing, which is not fun. You just need the port pin PB, PC, PE, etc. Yes, you're right. So these numbers, right? So this B0, these ones. So these are the microcontroller pins, the Atmega 32U4 pins, their designations, and these will be the same in both of these. So that's exactly the kind of mapping. I had missed this because I was referring to this diagram, which didn't have the PBPC nomenclature. And I went with the A0 naming scheme, got somewhere, but then I realized I need the these B0, B1, D0, C0, and so on both of the boards, right? So that's what I'm doing right now. I found, say, this diagram, which has those, and on the Pro Micro side, I found this, right? So there is, yeah, so this is the Teensy view, this is the Pro Micro view. Both have the BCD nomenclature, and those should be just maps. That's just the first level of mapping. You're saying the image on the Pro Micro is old. All right, this image. So there are two Pro Micro images. Yeah, this one is correct. Okay, that makes sense. And this one, I think, in the sense, this seems to be what one set of nomenclature is, which is this A0, A1 nomenclature, but we don't want to use that because it's a little confusing. So we will just use this. These are we know for sure that the internal microcontroller is the same, the 32U4, and hence we'll use this nomenclature to find the mappings and move from there. A red one was old. Yeah, that makes sense. Thanks for confirming that. Cool. So in terms of what we are doing here, right, we want to come up with this mapping type and the physical pin on the other microcontroller. So this is the Teensy, and this is the physical pin number here. I'm used to using physical pin numbers because that's actually what you use when you're soldering. So I'm trying to get to physical number mapping. Either it's a pass-through. For example, this pin is a pass-through because the exact same pin, A3 or ADC5 in this case, let's just confirm that. Pin number. All right, so why is this? So this is the Teensy side, right? Teensy 32U4 pins. So is this not a map then? Right, so fifth pin on top is F6. That doesn't make sense. So yeah, so this is F5, which is called ADC5. Interesting. And we are looking for that on the Pro Micro side. Okay, so I'm looking on the wrong place, right? So this is F5 is ADC5, and what I'm looking for here is F5 as well, right? So F5 here is on A2 pin, which I can directly use, right? So this isn't correct then. Yep. Nope. Okay, understood. So this is the confusion. Yeah. So the problem was between physical pin numbers and these written pin numbers, right? Which are actually off by one because of some things being called 5 volt instead of a number. So if I look at physical pin number 20, it is logical pin number 18 on the Teensy, which is here. Physical pin number 20. Yeah. You're saying, by the way, should have prototype Ergodox PCB with Pro Micro support. Thank you. That will be awesome. I'll just buy one at this point if somebody has that. So I thought of doing something about it, but like for now, I'm just trying to use these physical boards that I have with me, which you can't see on the front camera because they're green. I'll definitely experiment with these. If something goes seriously wrong, and certainly for convenience, I would want somebody to just use a PCB that supports Pro Micros. That's pretty common. For example, I was looking at the Lily design, right? They already went with 2 Pro Micros. So it seems like because of the cost of Teensy versus the cost of Pro Micros, and also the availability, particularly from the Indian context, Pro Micros are very easily available. It cost me, I think, 400 rupees per unit for the Pro Micro, versus any imported Teensy was at least 2,500 rupees, if not more. So yeah, it makes sense for having a Ergodox compatible design with Pro Micros. That would be awesome. Cool. So you have some, you're sending me links on Discord. Cool. Fine. That makes sense. I'll have a look at those. Thanks, Pudding. Awesome. For some reason, there you go. Music stopped. It had crashed. I think it's a good sign for me to actually end the stream because I'm hungry. And I think I skipped dinner a little bit. It's delayed, so I'll go. I'll pause at this point. So what we have done is for one half of the Teensy, we know what these are. These are not final because I want to minimize hand wiring and maximize either headers or firmware remapping. Headers are only useful when the exact same pin designation can be put down into the same spot, or by doing a firmware mapping, we can actually use the same header. So firmware here means use a header in physical connections. So that means just straight through drops, the Pro Micro just fits in, and it's a little bit of a jump through. So I'll try to find versions of these pins, the hand wired pins, which can be remapped. For example, instead of using B4, I can use whatever is here. So let's take an example there. So here it is D7. For pin number 14 is D7. So here it is B2. So if I just map it to B2 internally, so QMK with the Teensy will call this D7. Instead of that I have to just write B2. If I do that, I can just map this directly into the same pin, right? Physically. So physically pin 14 of the PCB will receive physical pin 14 of the Pro Micro. By physical pin, I mean this pin above this, so which is called 16 internally. So that's the confusion, but this pin, right? Just called B2 here. And so internally, I will just replace the QMK files D7 with B2, and it should just work. That's my assumption, and I'll just move with that for now. So in that manner, I'll minimize this hand wiring. I would have liked to finish it online here on the stream, but for now I need to take a lunch break or a dinner break. So I'll do that. If I come back right now, I might continue and finish this off in a second version of the stream. But mostly I'll go to sleep. So that's the plan. So this is fun for me because I get to chat with people who have been building keyboards, who are part of the local community here in India, and have lots of diverse experience. So that's the real reason I'm doing this stream. And the other reason is talking to people instead of just doing these things alone, just having people to chat with on any topic, right? That's another. The third most important reason is dedicating this time for me to actually do this project, right? Otherwise, taking even 2 to 3 hours out on a weekend is a little difficult because there are, I want to go out with family and so on. So knowing that I have to stream during this time will help me prioritize family time at some other time, and hence dedicate this to personal projects. So that's the main reason I'm doing the stream. Thanks to everybody who dropped in. I will end the stream at this point, and next week may do 2, like a Saturday stream and a Sunday stream, but the target is to finish off this mapping work in the spreadsheet. either offline or on streams whenever I get time, and be ready to actually breadboard this, which is put the Teensy pins in, put the Pro Micro pins, solder them in the headers, put them on a breadboard, wire it up, get QMK ready, the firmware, flash the firmware and test it out on a breadboard before I solder anything anywhere. That would mean to make sure that the firmware is ready and this concept actually works. I'll probably test a few pins with physical switches, and that's the idea. So that's what I'm hoping to do next week, and by next week I'll also have all of the soldering equipment and other parts that I was missing today, and maybe we can even start the first round of soldering by then. But for now, thanks to everybody who dropped in. It's really good to see the support for I was not sure if anybody will drop in. Last week I didn't tell anybody. This week I just announced on Discord and Twitter. So again, thank you for the support. Please drop by next time as well, and I'll see you all on Discord, in the keyboard Discords, or catch me on Twitter. I am Yoda_droid on Twitter. It's a new account I've created, which is not linked directly with my usual account. I'll just keep it like that for now. It's not like I'm trying to hide my name or something. I mean, my face is here. I just want to just start out separately and maybe link the two together in future sometime. But yes, I'm Vipul in real life. For those of you who know me, that's my name. And thank you for being here. Thanks for your support. Putting Andreophile, Lubaman, everybody who dropped in, GRK, Zorbid. Wow, a lot of folks dropped in over the period of the stream. So thanks a lot. It's been very, very interesting for me to try this experiment, and if it helps, do let me know either on Discord or anywhere you have my contact. Twitter, Yoda_droid is probably the best way to reach me on topics for the stream, and I'll see you in the next stream. Thank you so much. I'm wondering if I should raid somebody. It's not like I have a lot of viewers or something, but raiding a channel is, I think, a good way to build a community within Twitch. So let me see who is streaming right now, which we could raid. Awesome. It seems Big Omega also dropped in at some point in time, and People Trio as well. So awesome. I think a lot of folks dropped in. Some of you didn't speak. So next time you drop in, please say something in chat. Interacting with people is pretty much the main reason why Twitch is such an awesome platform to stream. Right. And now I'm looking for somebody to raid who is doing some sci-tech stuff. Let me see. I may not find anybody. If somebody is doing keyboard stuff, I think they might be interested. Or you folks might be interested in continuing to watch somebody. I'm not even sure how many people are on the stream right now, but that's okay. Awesome. So one of my most favorite streamers is streaming right now. I'll rate them. She is Noab Cat. It's amazing how she's kind of built her stream from a very early experiment over a few years. She's one of the most famous science technology streamers. She wrote the AVR Girl library, which I might actually use to program the microcontroller in this case. So I'm going to go and give them a raid. It's just a way of saying, hey, thank you. And I usually watch their stream all the time, and she does an awesome job. She's a very chill streamer. So yeah, if you're around, say hi, and good night, good evening, good day for you. Now let me figure out how to actually raid somebody. Never done this before. Twitch autoplay. No, thank you. Right, there you go. Start right there. It is. I think it should happen. one viewer. Awesome. No worries. So it's just me, I guess. And let's see what happens on Knobcat stream. Bye bye.